All right, well, let's go over the review questions for this chapter on speed and acceleration. So, and because we're going over the review questions, that means we're coming up on a test, and the test should be tomorrow. So plan on that, and tonight you're going to want to look over these review questions and go over them so that you're ready for that test. So the first question said, calculate the average speed of a car that has traveled 350 miles in 7 hours. So we're going to end up using this. We're going to use this equation where speed equals distance divided by the change in time. All right. So in order to do that, how far did that car travel? Well, 350 miles. How long did it take him to do it? 7 hours. So we're going to take 350 divided by 7. When you do that, you're going to get an answer of 50, and then neither one of those units cancel, so it's 50 miles per hour. All right. So that car is traveling an average of 50 miles an hour, being that he traveled 350 miles in 7 hours. Second one, does the speedometer of your car tell you the average speed or the instantaneous speed? Well, your speedometer, because it changes back and forth all the time, that's actually going to be your instantaneous speed. It's only telling you your speed right now. And it doesn't tell you what your speed is going to be an hour from now. It doesn't tell you 3 hours from now. It's only telling your speed right now. Well, what is average speed? Well, average speed is what we did here. This person's probably heading to Florida or something, and he's traveled in the last 7 hours 350 miles. Does that mean he was going exactly 50 miles an hour the whole time? No, he was probably going 70, and then he was going 20 when he got into some traffic, and then he got back up to 50, then he was going 70, and then he was going 62, and his speed was going all over the place, up and down. But all together, he traveled 350 miles, and it took him 7 hours. So his average was 50 miles per hour. All right. So remember that your speedometer is instantaneous speed. Question number 3. It's cold in my room right now. What's the difference between velocity and speed? Well, remember that speed is distance divided by time. And then if we want velocity, what we've got to add to what's behind me right there is we got to add direction. We got to say, is that car going north? Is he going south? Is he going east? Is he going west? Which direction is he going? That will give us velocity as long as we get the direction. Question number 4. Calculate the acceleration of a car that goes 0 to 60 miles an hour in 6 seconds. All right. So now velocity then, not velocity, acceleration. The equation for that is acceleration equals final velocity minus initial velocity, all that divided by the change in time. So what was his final velocity? How fast did he get going? 60. What did he start as? What was his initial velocity? 0. So that's my top part. Now, how long did it take him to do that? And this is also, this is miles per hour for both of those. And this is, he did this in 6 seconds. So we're going to take, that's 60 then, divided by 6. So it equals, he did 10 miles per hour every second was his acceleration. So in the first second, he was going 10 miles an hour. In the second second, he was going 20 miles an hour. In the third second, he was going 30 miles an hour. So he was increasing his speed by 10 miles an hour every second. That's what acceleration means. All right. Now it says find the answer in miles per hour per second. Well, that's what we did here, 10 miles per hour per second. Then the second part says change that answer to miles per second squared. Or we've got to make it miles per second per second. So we got to get rid of that miles per hour. So how are we going to do that? Well, how many minutes are there per hour? Well, there's 60. So we're going to multiply by, and we got hours on the bottom, so we're going to go, there's 60 minutes per 1 hour. Okay. So we're multiplying 10 by 60 over 1. But then we got to get rid of minutes, so we're going to multiply by, there are 60 seconds in 1 minute. Now what does this do? Lets me get rid of minutes, lets me get rid of hours, and now I get a unit of miles per second, right? So we got to go 10 times 60 times 60. Well, what does that turn out to be? Oops. Did I make a mistake? Oh, yeah, I did, because my hour is on the wrong side. Oh, man. I made a mistake. Let me try that again. Notice my hour is on the bottom. And I put hours on the bottom. Sorry. I'm not perfect. Well, because I catch my mistakes. So we want hours on the bottom, so we need hours on the top. In 1 hour, there are 60 minutes. We're still using the same ratio. I just had it backwards. So now my hours is on top, hours on the bottom. So I can cross those two out. But now I gotta get rid of minutes. So we're gonna multiply. We got 1 minute has 60 seconds in it. That lets me get rid of minutes. Now I have miles per second per second. Now I got it. So now it's 10 divided by 60 times 60. What does that equal? 0.0028 miles per second every second. Right. So it's not very much, but think about the idea. How many miles do you travel in a second? Not very many. So it's a really, really small amount of miles per hour every second. I know that's kind of tricky, all right, but it's just something to really see if I can challenge you a little bit once in a while. All right, number 5. What factor causes a toy car to slow down after being pushed across the floor? So you take a car, push it across the floor. As we all know, according to inertia, it should just keep going and 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 never stop. But it doesn't. It stops. Why does it stop? Because of friction, which actually I could use some right now because my room is cold right now. Because then also, where does that energy then go? Well, exactly like that. I'm cold right now. So I could use some friction in my hands to make my hands what? Warm. Right? And so basically that friction produces heat, and then the heat energy goes off into the atmosphere, and that's where we lose that energy to. It's not destroyed. It doesn't go like disappear. It becomes heat and goes floating off into the atmosphere. All right, number 6. How can friction be reduced? There's 2 different ways. One way is we can oil the surfaces. We can make them slippery. The other way is if we reduce the mass, like the idea of what Ford Motor Company did, where Ford Motor Company changed their trucks into aluminum, so less mass, which reduces friction, therefore it makes it so they can get better gas mileage. All right, number 7. Describe the difference between a net force and a balance force. Well, we'll go with the idea of a tug of war. All right, tug of war. If the 2 teams are pulling on that rope evenly and the rope isn't going anywhere, that's a balance force. So I get the same amount of force in both directions. But now, if all of a sudden I got a big force going this way and a little bitty force going that way, well, which way is the rope going to go? It's going to go that way. This team over here is going to win. So this is a net force in that direction. This team has a greater force. So in a net force, there's a winner. In a balance force, it's a tie, is a way to remember that when we're looking at a tug of war. All right, number 8, describe Newton's first law of motion. Give an example of each of the 2 parts of the law. Well, the first part of that law is an object at rest stays at rest. All right, so we could say a car sitting in my driveway. Where is it going to be an hour from now? Still sitting in my driveway. Where is it going to be tomorrow? Still sitting in my driveway. It's not going to all of a sudden just like take off on its own. No, it's just going to sit there according to the law of inertia. Now, oops, there goes my light. Hold on. All right, second part to the law of inertia is that an object travels in a straight line until another force acts upon it. So that means if all of a sudden I throw a ball, right, that ball is going to go straight. And it's just going to go straight and straight and straight. Well, that's freaky as it comes towards you. But it's going to go straight and straight and straight and straight until another force acts upon it, and it's going to cause it to change direction, speed up, or slow down. Now, as we all know, if I throw a ball, that ball doesn't go forever and ever and ever. So I thought I just said it was supposed to. But what happens is there's friction, right? As it runs into something, like goes down on the floor and starts rubbing on the floor, and that produces friction, loses energy to the heat. We also have gravity that pulls it down, so we do have another force on it. So really, this whole idea of inertia, we have to think like out in space on this whole idea that if there's nothing else around, then that ball is just going to go straight all the way, all the time, right? It's not going to slow down. So, all right, that takes us to number 9. How does inertia affect a car going around a curve on an icy road? So you're driving down the road in your car and it's icy out, and you come up to a turn and you turn. Right? Where does the car want to go because of inertia? It wants to go straight. So you got to make sure you're going slow enough so that the friction between the car tires and the road is enough to overcome that inertia that wants to keep you going straight. And that's why they suggest in driver's ed, because I used to be a driver's ed teacher, to make sure that you slow down when you go around corners when it's icy out, because inertia wants you to keep going straight. And we got to have enough friction with the roadway to make sure that we can turn around the corner. Number 10, what keeps the car on the road if the car is dry pavement? Well, we just talked about it a minute ago, friction. And friction is what keeps it on the roadway. If we don't have enough friction, then we're going to slide all over the place. So, and that's also why when it's rainy out, you got to slow down a little bit, because the rain then makes the road slippery, because it does reduce the friction of the tires with the roadway. Number 11, why would your car slide out on dry pavement? Oh, so I go around the corner and all of a sudden my back end slides all around. I'm drifting. Oh, there's fun stuff to do, but it's dangerous. Why is that? Because there's not enough friction. Right, the friction went down, and because there's a greater amount of inertia. All right, the faster I go, the more my car slides out around the corner. All right, so higher inertia and less friction. Think like the tires they put on drifting cars. They're actually kind of slick tires. They try and reduce that friction to make it so that they do slide when they go around the corner, to make it so they can drift better. Number 12, looking at those graphs. What do each one of those graphs represent? Well, the first one, we got the speed is going up over time. Well, that's exactly what's happening. It's speeding up over time. So this is an increase in speed. Graph letter B, the speed's going down over time. So that means he's slowing down. His speed is getting less over time. Well, now look at number C. Number C is challenging because all of a sudden we changed it to distance over time. Well, this distance is over time is not changing. The object is here for a certain amount of time. It's there for a certain amount of time. It's there for a certain amount of time. It's not changing its distance. What's it doing? Just sitting there. It's not going nowhere. All right. Then we got the last one. Notice it's distance versus time. So it's not speed versus time. This is distance versus time. So he's increasing his distance at a constant rate. He's 1 mile away, he's 2 miles away, he's 3 miles away, he's 4 miles away. Is he increasing his distance like rapidly? No, it's kind of like this constant increase in distance going up on that graph. So therefore it's a constant speed, all right? Now that seems kind of weird because you look at the first one and go, well, that looks like the same graph in letter A. But notice the first one is speed versus time, and letter D is distance versus time. So there is a difference between those two. All right, before we go to the other part, I'm going to switch to go to part number 2 because I'm just about out of time. So we'll see you in a minute.